Hi everyone, welcome to this video on compiler design. In this video, we are going to discuss specifically on the introduction to syntax analysis, especially the need and role for the syntax analyzer. Let us dive into the video. We know very well that the syntax of a programming language constructs can be specified by CFGs or BNF notation. Why should we specifically use grammar for representing the syntax of a programming language? There are four reasons. A grammar gives a precise yet easy to understand syntactic specification of a programming language. It is easy to represent. With grammars, an efficient parser can be constructed automatically. There are several open source tools which can transform the syntactical representation from CFG to an automated syntax analyzer. It can implement easily. Third, the grammar is useful for translating the programs into correct object code. It is easy to translate the content from grammar to object code. It is also easy for detecting errors. That is the third most reason for using grammars to represent programming language. Fourth, a grammar allows a language to be evolved or developed iteratively by adding new constructs. If we have developed a CFG for language 1, it is easy for you to extend the CFG to represent for language 2. And that is the power of grammars to be used as constructs for programming languages. What do we infer from this picture? This is the parse tree for a complete program. A program begins with void main. In terms of C language it is represented, but yet we can well understand and well connect with variety of languages as well. Void main, opening bracket, closing functioning bracket, and the entire program lies with the opening and closing curly brackets, where these two brackets can encompass declarations and statements comprehensively. And we can very well connect how each declaration statements are and how each statements are divided into their own children or divided into subportions, where the entire program is viewed as a tree. And that is why the compiler or that any translators are able to identify the misbalance between brackets and any syntactical errors that a program has. Topic 1, as we said, we discussed the need and role of the syntax analysis, and there comes the checking the syntax of the program. Obtaining the sequence of tokens from the lexical analyzer is also a task of the syntax analyzer. Generating parse tree or syntax tree for the set of tokens received, while indicating the errors if exists, is also a responsible role of a syntax analyzer. Let us understand the same from the picture identified from the phases of compiler. There is a source program fed into the lexical analyzer which gives us the token, while the parser or syntax analyzer also seeks the next set of tokens from the lexical analyzer. It is a cyclic routine. Once the parser gets a group of tokens, it is able to generate parse tree or syntax tree, which is fed into the rest of the front end, taking it forward to the intermediate code generation or intermediate representation called IR. In addition to the communication between these three boxes or these three phases, they also communicate with the data structure called symbol table to get and enter some information into this or from. There are three general types of parsers available: universal parser, top-down parser, bottom-up parser. Universal parser is the one which is represented or initiated by Koch Younger Kasami, called CYK algorithm, invented in the early of 1970s, where This universal parser will say yes or no for a given string, whether or not it can be derived from a given grammar. Whereas the top-down parser tries to build parse tree from the root node to the leaf node, checking whether or not the given string belongs to the grammar. It constructs from the root. On the other hand, vice versa, the bottom-up parser tries to construct parse tree from the leaves way up to the root node, starting from the string and ending up with the root node called start symbol, checking whether or not the string actually belongs to the grammar. All the three parsers do the same task of checking the membership of the string with the grammar, but everyone does it in different way. If it does universally, universal grammar. If it does from top to bottom, top down. If it does from bottom to top, bottom up. The names imply the concept, but implementations differ, and let us discuss how they are done. In either of the cases, the input to the parser is scanned from left to right, one symbol at a time. This is the usual procedure which well applies to lexical analyzer as well. The output of the parser is some representation of the parse tree for the stream of tokens that comes from the lexical analyzer. Collecting information about various tokens into the symbol table is also a responsibility or task of the parser. So how can we represent the syntax with grammars? There is a simple example down here. Assignment is represented usually as an identifier assigned with some expression. A variable name equals to some expression is the regular assignment statement, which follows expression can be a single term or expression plus term or expression minus term. The term can also be a factor, term or factor, term divided by factor, where the individual factor can be an identifier, literal or parenthesized expression. This is a simple grammar representing the expressions or arithmetic statements or assignment statements. There are two different parsers. We said there are actually three, while the syllabus or the major focus lies with bottom up and top down parsing. We already discussed or understood the concept of left recursion, where the non-terminal appears before and after the arrow mark of the production is termed to be a left recursive grammar. In this example, we have the production called E tends to E plus T or T, where the E appears immediately before and after the non-terminal. So the first production or this grammar is said to have left recursion. This left recursive property is not suitable for top-down parsing because it will take the parsing process into infinite loop, and probably this parsing, top-down parsing, must eliminate left recursions if they are available, and hence top-down parsing as a first encounters or does the removal of left recursion, while it is not essential for bottom-up parsing. Syntax error handling is also an essential part of syntax analyzer. The compiler has to assist the programmers in locating and tracking down the errors. Error handling is left with the compiler designer, but the proper handling of errors right from the start can simplify the structure of compiler and improve the error handling process. And while the compiler is designed itself, there must be mechanisms for handling the errors, and so that the compiler can continue the compilation process till the end. It must not stop in between when it finds an error as like an interpreter. There are probably several types of errors, respectively four mentioned from the regular textbooks: lexical errors, syntax errors, semantic error, and logical error. Any misspelling encountered in the program is termed to be the lexical error. Syntactical error is an arithmetic expression with unbalanced parenthesis, misplaced extra or missing semicolons, any syntactical kind of thing other than the lexical contents, it is termed to be the syntactic error. Maybe the lexical error and syntactic error may not be present in the program, but the program might encounter semantic error. There is a mismatch between the operators and operands, meaning that C language has plus operator. It can have only numerics as the operands, cannot have strings as the operands. While the syntax is accepted by the compiler, the semantic or the logic is not acceptable by the compiler. It will throw errors when the program is run. There are logical errors also which might not affect the compilation process but will affect the output of the program. So using double equal to is the actual logic of checking A equal to B. Using A equal to B is not the actual way of checking whether A and B are equal, and these kind of errors are termed to be logical errors. So what is the goal of error handler? It must report the presence of errors clearly and accurately, recover from each error quickly through and detect subsequent errors, add minimal overhead so that the program can be corrected easily. And reporting the presence of errors is also the primary task of the syntax analyzer. It must return the pointer to the position where the error is located or detected, similar to the lexical analyzer phase. There are 4 error recovery strategies mentioned and in use for the syntax analysis phase. Let us identify what are those. There are 4 techniques as said: panic mode recovery, phrase level recovery, error productions, and global corrections. With these 4 mechanisms, the syntax analyzer can continue from finding out the first error to the end of the program, and it can continue compilation process till the end. So these 4 recoveries can help the syntax analyzer continue further. And thank you for watching this video. We will meet in the next video. Thank you.